6.1b is on adding and subtracting radicals. So we want to be able to add or subtract two or more radicals. So the key to this is remembering what like terms are. And so we'll talk about what like terms mean for our radicals or our roots. So like terms are when you have the same thing under the radical. So for example, the square root of 3 plus 2 times the square root of 3 could be combined because they have the same thing under the radical. If we're looking at the square root of 5 plus the square root of 7, those cannot be combined because 5 and 7 aren't the same thing. Okay, so whenever you're adding, you're thinking about, well, can I combine those? Are they the same thing? I can. The square root of 3 and the square root of 3 are the same, but the square root of 5 and the square root of 7 is like saying I have 5 apples and I have 7 oranges, so together I have 12 watermelon or whatever. It just doesn't make any sense. Same if you had something like 4 plus the square root of 2. You could not combine those because they aren't like terms. Again, it's that whole apples and oranges. You can only combine them into one number if they represent or if they stand for the same thing. So please keep that in mind. So we're going to start off with simplifying these expressions. We have letter A is the square root of 2 plus 3 square roots of 2. Well, notice that we do have 1 square root of 2 right here, so there's an invisible 1 in front of that. So it's saying we have 1 of something plus 3 of something, which tells us we have 4 of that thing. So in this case, the thing we're talking about is our square roots of 2. So we have 4 times the square root of 2. In other words, 4 square roots of 2 as our answer. You can either say it as 4 times the square root of 2, or you can say 4 square roots of 2. It's 6 of one, half a dozen of another for how you want to read it. Here we've got 4 times the square root of 3 plus 2 times the square root of 3. Well, again, we have 4 of something plus 2 more, so that gives us a total of 6. 6 of what? 6 square roots of 3. And that's how we combine them. Now, subtracting, very similar. 9 square roots of 5 minus 1 square root of 5. Anytime it doesn't have a different coefficient in front of it or a different number in front of it, you always have one of them. So if we have 9 of something and we subtract 1, we would have 8. Well, we have 8 of what? 8 square roots of 5. So 8 times the square root of 5 would be our final answer. Sometimes they don't have the same radicand, right? Remember, the number underneath your radical is called the radicand, so sometimes those numbers aren't the same. And when that happens, you need to see if you can simplify. So looking at 3, well, the factors of 3 are just 3 and 1, so we can't really simplify that at all. That's already completely simplified under our radical. 12 we could write as 3 times 4, and 4 we could write as 2 times 2. So we've got 3 times 2 times 2. Well, we have a group of 2, which means we have a perfect square under our radical. And for our simplifying, remember, we can't have a perfect square under our radical, we can't have a fraction, and we can't have a radical in our denominator. So we need to simplify this square root of 12. So I'm going to rewrite this as 3, right, here's my 3, times the square root of, 3 times 2 squared. There. And now we can simplify. Well, notice how our 4 times the square root of 3, we don't need to change that at all. Nothing's happening there. But we can say the square root of 3, we can't simplify that. But the square root of 2 squared, those will cancel each other out. And our 2 will come outside of our radical because we completed that operation. We evaluated the square root of 2 squared, and so that is no longer under our radical. So look at what we have. We have 4 times the square root of 3 minus 2 times the square root of 3. So we have 4 of something minus 2 of the same thing, which means we have 2 times the square root of 3 as our answer. So since we made it, right, since we simplified and ended up with the same radicals, that's why we could combine our like terms. Now it'd be a good idea to pause and see if you can do letter E for yourself. Well, again, we need to simplify. So 45 we could write as 9 times 5, and 9 is 3 times 3. So we have this group of 2. 5 is just 1 times 5, so we really can't simplify anything there. So we could write this as 3 times the square root of 3 squared times 5. And again, I just rewrote my factors underneath my radical. Plus 2 times the square root of 5. And we can't simplify that one, so it just gets to stay. Well, 3 times the square root of 3 squared. Those cancel each other out, so we have another 3 that comes outside of our radical. And then this 5 is stuck in there because it's not a group of 2. And 2 times the square root of 5, again, we can't simplify that. So anytime you take something out of your radical, right, remember we are multiplying right here, which means when we took this number out or when we evaluated it and it came out, we are multiplying those numbers together. So 3 times 3 would give us 9 times the square root of 5 plus 2 times the square root of 5. Well, 9 of something plus 2 more gives us 11 times the square root of 5. So that would be our answer. Just have a couple more to look at. So letter F, again, a good idea to pause and see how far you get. So we have 3 times the square root of 3 minus 2 times the square root of 12. Well, 12 we could write as 4 times 3. And 4 we could write as 2 times 2. Again, remember, once we factor it, we're done with those numbers. Okay, because 2 times 2 times 3 equals 12. That's what we're doing when we're factoring. We're just writing that original number another way. So 3 times the square root of 3 gets to stay because we can't really simplify that square root of 3 at all. But we could write negative 2 times the square root of 12 as negative 2 times the square root of 2 squared times 3. And now we're just simplifying. 3 times the square root of 3 minus 2 times, well, the square root of 2 squared tells us that we have a 2 that comes out of our radical. And then that 3 is just stuck in there because there was just one of them. So again, we don't do anything to 3 times the square root of 3, but 2 times 2, or a negative 2 times 2, would be negative 4 times the square root of 3. Well, we have 3 square roots of 3 minus 4 square roots of 3. Well, if we have 3 minus 4, that would leave us with negative 1. Negative 1 of what? Negative 1 times the square root of 3, which you could also write as negative square root of 3. Either of these answers is acceptable. So this is how we add and subtract our radicals. So you add and subtract the like terms. Notice that when we added, the radicals did not change. What was underneath the radical did not change. If we had the square root of 3 plus 2 times the square root of 3, we combined our coefficients out in front, but that number underneath the radical did not change.